In the real world, people can see, hear, smell, touch, and taste. These sensory cues can also be provided by virtual reality systems where multisensory feedback is integrated. As it is complicated to study the effect of multisensory feedback as a single factor, we created a design space with these diverse cues, categorizing them into an appropriate granularity based on their origin and use cases. To begin to explore the design space, we selected certain cues for focused study. To examine the effects of tactile cues during walking in immersive virtual environments, we selected movement wind, footstep vibration, directional wind, and footstep sounds, and investigated their influence and interaction with each other in more detail. We developed an immersive VR system with a non-fatiguing travel experience and multisensory feedback including visual, audio, wind, and floor vibration. Within the floor vibration module, 4 actuators are installed under a raised floor, generating vibration based on the audio signal they receive with varying amplitude and frequency. The wind delivery hardware consists of 8 pan-tilt fan units surrounding the user, which can be quickly pointed towards or away from the user. Low latency movement wind can thus be generated. The wind module can also generate a consistent experience by adjusting the wind speed and direction based on the user's physical motion and proximity to each fan unit. With an accelerometer installed under a swapper chair, the user can control movement using a Chair I/O interface. The user sits at the center of the cage, wearing an Oculus Rift DK2 HMD and a noise-canceling headset, and holds a Wiimote for button confirmation. Chair calibration is required for first-time usage. The user tilts the chair forward, backward, left, and right to calibrate. The VR simulation contains visual and ambient audio cues along with footstep sounds. The user can walk around in the virtual scene by tilting and rotating the chair. In the physical world, the system provides corresponding tactile feedback, including movement and directional wind, and footstep vibration. In this paper, we present 2 experiments using our VR system. Both experiments investigated the effects of different sensory cues on spatial orientation and user experience. In the first experiment, all conditions had visual feedback and ambient sound. We varied 3 different cues: footstep sound, footstep vibration, and movement wind. The second experiment was inspired by participant feedback from the first experiment. All conditions in the second experiment included visual feedback, ambient sound, and footstep vibration. We varied only movement wind and directional wind. There were 24 and 16 participants respectively in the first and second experiments. Both experiments used a within-subjects design. The participants performed a triangle completion task in both experiments. The task required participants to travel a triangular path, of which the vertices were marked with rings in the scene. As soon as the participant reached the 3rd ring, all of the rings disappeared, and he was asked to return to the initial position in the first ring. In the 2 experiments, each participant first filled out a demographic questionnaire, then changed to the experiment shoes to ensure the same sensation of floor vibration. After going through the trials for each condition, the subject filled out a subjective questionnaire measuring user experience. Please refer to the paper for more detailed descriptions and results.